I'm Max Donath, and welcome to our seminar series on advanced transportation technologies. As we've done these past few weeks, I'm going to welcome Hannah Grun first to come up and just take care of some housekeeping, and then I'll take over and introduce our speaker.
Welcome, everyone. For those of you who are watching via the web, we ask that you please sign in with the number of people watching at your location in the chat box at the upper right-hand side. We are required to report our viewership rates to the US DOT and would appreciate having the most accurate count possible. For students in the room, if you are waiting on a write-up back from me, please see me after the seminar is over. And for the live audience, please hold all of your questions until the end. We'll be passing around this microphone so that the web audience can hear what's being said, so please make sure to hold it close to your face. Thank you.
I am honored to introduce Professor Gebre-Egziabher as our speaker today. It took me a while to convince him to give this seminar. He's been involved in this area of working with drones and unmanned aerial vehicles for quite some time. And I remember he worked with the Minnesota State Patrol helicopter folks and looking at the risk of drones, mixing it up with State Patrol helicopters, and what are some of the risks associated with that. And that was in 2006, 2005, at that time frame. So about 10 years ago, before all the buzz on drones that we hear about in the newspaper these days. Professor Gebre-Egziabher has been all over the place. He received his PhD at Stanford University. He was a commissioned naval officer for 6-7 years, left the service as a lieutenant in the Navy. He worked with Naval Sea Systems Command in Washington, D.C. for quite a number of years, and is an instrumented rated pilot. And I'm sure there will be a lot of questions after this talk. So without further ado, let's welcome Professor Gebre-Egziabher.
Is the microphone on? All right. So thank you, Max, for that welcome and the invite, and thank you, everyone, for being here this afternoon. I'm going to spend more time on the challenge side of the problem because, as you'll see quickly, there's all kinds of things we can do with these vehicles. There's all kinds of things that I can't imagine that different people have and their vision for doing with them. But all of those come with some challenges that we need to address before we could actually use these on a day-to-day application. So I'll talk a little bit about the opportunities, but also talk about the challenges and some of the things we're doing here at the U of M to address some of these challenges. Before we get into the meat of the topic, let's kind of define some backgrounds, terms and ideas, basically. So first of all, unmanned aerial vehicles. They're basically aircraft that are operated autonomously, right? Could be completely autonomous, or there could be someone on the ground remotely operating them. Popularly called drones. That term bothers me, but I guess I'm losing, and that's becoming the standard term, so we'll call them drones. Or they could be called RPVs or ROVs. That's another term that's used for them. There's all kinds of envisioned applications for these vehicles. So they're being envisioned for what are called the 3Ds, or the dangerous, the dirty, and the dull missions. And if you want to list some of the dangerous ones, for example, and that's some of the things we do at the UAV lab here, is the dangerous is like flight testing. They kind of are a nice surrogate for big airplanes, where in the past you'd have to put a test pilot in. Now you could put an unmanned aircraft and do things that are risky with it. The dirty, you could talk about things like environmental monitoring. So they're being used, for example, to monitor smokestacks of factories and sort of things like that. Precision agriculture, we're using for chemical spraying, perhaps. And then you got the dull side of it, which is, well, dull not in the sense that it's boring, but it's continuously looking at infrastructure or inspecting something might be dull. So they could take that kind of dullness away from human operators. So those are the kind of applications they're being looked at for. What we're going to do in this talk, I'm going to look at just two cases of where we could use them in traffic and infrastructure surveillance. and then talk about the limitations associated with them. And I'm going to focus on what are called small or class 1 and 2 UAVs. They come in all kinds of size and ranges. I mean, the Global Hawk shown here is about a 30,000-pound UAV. It has a wingspan of about 130 feet, so it's about the size of a 737 if you want to think of it that way. Completely different issues, completely different problems. We're just going to focus on these, which are the ones that are most relevant for what we're going to be talking about today, so small UAVs. So the classification of UAVs, I said there's a large span of capabilities, sizes. What we're going to focus on are just what are called the Group 2 and 3 UAVs. And basically, one way to think about them is they weigh less than 55 pounds and they fly slower than 200 knots. Actually, a better number is 100 miles per hour, so something in that area. And they don't fly very high, even though the classification of these is up to 3,500 feet. Usually we're talking about applications less than 500 feet above the ground. All right? So we're going to focus on those. Again, it's a big area, so we're just going to narrow down and look at one particular aspect of it. All right, so one more piece of terminology is the term UAV and UAS gets thrown back and forth interchangeably, and I will do that too. To be correct, though, we should distinguish between those two. The UAV, the unmanned aerial vehicle, is the aircraft that's in the air, that's doing the mission, that has a payload on it. However, associated with that, there has to be a ground station. There has to be someone on the ground controlling it, commanding it, telling it to do what it needs to do, and that's an integral part of this. So the ground station plus the radio data links that are used to send information up plus the aerial vehicle together form what's called a UAS, an unmanned aerial system. So when we talk about UAVs, we should really be talking about the entire system, so it should be the aircraft, the data links, and the ground operator. And you'll see maybe in about 10-15 minutes when I start talking about how you operate these aircraft legally, this part of the picture becomes important. The ground, the operator is actually an integral part of all of this. All right. So the roadmap, I just did some background. What I want to do next is to talk about a little bit of opportunities, who's using UAS and what applications. And what I'm going to use that for is to set the groundwork for the challenges. And again, if there's anyone here interested in UAVs or in the audience, you probably are interested in knowing what are the issues. What do I need to be aware of before I could use them? So there's some regulatory issues. We'll talk about those. And we'll anchor that with technical challenges that are out there that are still being worked on, that are not addressed. And then I'll give a summary and then open it up for some questions. So that's the roadmap. That's what we're going to do. All right, so let's talk about opportunities. And before I do that, let me show you this table. So first of all, to be able to operate UAVs legally in the US today, you have to have permission from the FAA, and we'll talk about the details of how to do that. Don't do it without a permission. It's going to be costly. Or starting to become costly these days because they're beginning to enforce the rules. Anyway, so this table was generated from the list of folks that applied for permits to operate UAVs last year. And so based on that, what we see is aerial photography or aerial surveying seems to be the place where there's a lot of application for permits going on. However, this is kind of misleading because there are some other applications like precision agriculture, infrastructure inspection, which are definitely going to be more and more prevalent as time goes on. But again, there's a lot of technical problems that have to be solved before those become turnkey solutions that people could use. So we'll talk about some of that later on. Now, if you look at traffic and infrastructure surveillance use cases that are out there, they're being used, for example, for accident scene reconstruction, where there's an accident, you want to take pictures and get a nice map of exactly what went on for maybe lawsuits later on. So some highway patrols have been using them for that. Emergency scene management, fires and things like that, there's some use on that. Power line inspections, they've been used for that. Flare stack inspections, and the blue here is a link. I guess we'll make the presentation available after this, so if you want to, you could go ahead and click on that, and it sends you to a very nice web page put together by a consortium of small UAV folks that want to use small UAVs. And there are a lot of nice videos of small UASs being used for inspection purposes, dam inspections, bridge inspections, railway inspections, and I'll talk about these two next. All right, even though you don't consider this infrastructure, another place where there's a big call for UAS is in agriculture. But again, that's a different topic. It's something we're working on quite a bit here, but I won't talk about that today. Unless folks want to ask questions later on, I could talk a little bit about it. So, two cases that you could look at where UAVs, drones, UASs are being used. One, infrastructure inspection, where this photograph and the details associated with this I just took from Crossroads, which is a blog or a newsletter, if you will, by MnDOT. And there's an article there, and I actually suggest if you're interested, go ahead and take a look at it. It's a really nice write-up about the plans to use UAS for inspecting bridges. In this case, you see a small quadcopter trying to do inspections of a train trestle or bridge. And one application is exactly this. The UAV becomes a platform for carrying a payload. It could be a camera of some sort. And that camera could be used to inspect closely what's going on with that structure. Now, as you can see, this is a metal structure, and you have this UAV very close to it. As I'll talk about in a little bit, one of the key sensors used on most of these UAS is GPS. And this is actually a very bad environment for having GPS. It's a multipath heaven. Reflection of signals are going to be coming off of these structures, so that could affect some of the performance. But those are the kind of things, those are the challenges that have to be addressed or looked at when looking at using UAS for these kind of applications. But this is one, I guess there's a compelling economic case to being made for it. I walk to work every day. I walk over the Franklin Street Bridge these days, and they're doing some inspection and repair of it, and the amount of infrastructure set up there for doing that type of work is quite extensive, and this might simplify that. The next one, which I'll talk a little bit more about, is, and it's a really interesting one because there's a really interesting project with the FAA going on related to this one, is railway inspection. So just to put things in context, in 2014, there were about 500 derailments in the US. The numbers are about 35 injuries resulting from that and $94 million in damage. Now, there are two ways to look at that number. You could say that's kind of a small number, only 35 people injured and only $94 million wasted. The other way to look at it is the numbers are that small because there's quite a bit of inspection and quite a bit of effort that goes on in the background to make the railroad safe. So just to use one particular rail line as an example, and I'm using this for a very good reason because you'll hear about it a little bit later. If you take a look at Burlington North and Santa Fe, they have about 32,500 miles worth of railway track in the country, and every foot of those railways have to be inspected at least twice a week. So they're very, very interested in trying to automate this process, and this May, a program was launched called the Pathfinder Initiative, which is a joint collaboration between the FAA and BNSF looking at how to use UAS for over-the-horizon type of operations, and particularly their interest is to be able to inspect railroads like this particular section, which is out in somewhere in the middle of the state of Washington, I believe, where this picture was taken, where it's very remote, where it's very hard to get people out there. Is there a way to make teams of human operators and UAS do the inspection and automate it and be able to reduce the cost? So another really compelling case in transportation infrastructure management where UAS use would be beneficial. So the reason I brought this one up as an example is because this Pathfinder initiative is a good example of what remains to be done. Again, everyone, I shouldn't say everyone, most everyone is convinced that there's great economic benefit to using them in infrastructure, surveillance, management. However, there are technical issues that have to be addressed. So what I want to do in the next remainder of the talk is talk about the regulatory and the technical issues that one has to be aware of before using them for these kind of applications. Again, anyone, I should say anyone, there are people that are interested in using them for different applications, and again, you can't list all those applications. That table I showed you at the beginning shows you that there's a great interest. The question then is, I have a particular interest I want to apply them for. What are the things that I need to be aware of, and what are the limitations? So I'll spend the rest of the talk talking more about those issues. So the challenges. What are the challenges for the particular applications where UAS can be used? So let's start with the regulatory part of it. And to appreciate what the issues are, I'm going to go back and try to set up the stage as to why there are rules out there for operating UAS and what the concern is. So if there are pilots around here or folks that fly airplanes, you're very familiar with this diagram. If you're not, let me set it up and tell you what it is. So if you look at the airspace around the United States or most anywhere in the world, it's actually parceled up into different sections with respect to aircraft operations. So in the United States, we have airspace that are classified as Class A, Class B, Class C, Class D, all the way to Class G. And to operate in these different regimes, you have to have different equipment, different procedures, and different rules of the road, if you will. All right. So Class A is basically the place above 18,000 feet where mostly commercial transport aircraft fly. Class B are airspaces around large, busy airports. So around MSP, for example, there's a large Class B airspace there. Class D and C airspaces are airspaces around smaller airports. Well, Class Cs are not really small. Class Ds are kind of small. And then the rest of it is as shown here. The big reason why we have this delineation of the airspace is to ensure safety. Basically, it's to make sure that airplanes don't run into each other. Because again, depending on which airspace you're in, you have different requirements. For example, if you're operating here, Class A, you're always in contact with air traffic control. They're always tracking you. You have to have particular equipment on board. To operate in a Class B airspace, like around here, again, it's pretty strict and pretty stringent. There are certain equipment requirements that you have to have. And it gets less and less stringent as you go down the space. So if you're going to operate UAS, first of all, you need to be aware what kind of airspace you're going to be close to and what kind of airspace to avoid because of safety reasons, all right? And the other thing about the laws is they are there to protect the public below from unsafe operations. If you look at the rules, there are detailed instructions as how close you can fly to structures and things like that to make sure that you don't, cause damage. Now, it seems common sense that you won't go into particular airspaces and do things that you're not supposed to do. However, apparently it doesn't seem to be that way because there's a lot of UAS use happening these days where things that shouldn't be happening are happening. So, and that's why the rules are I guess, being put in place. So I brought three of them here, just three case studies from just recently where things were happening with UAS that should not have happened. The first one is there was a case out in California where UASs were being operated and they were interfering with public good. These were the fires this past summer in California where firefighters were using aircraft to put out the fire, and then there were a lot of gawkers using UASs to actually see what was going on to the point where pilots were afraid of flying, actually, so they had to stop flights at that area. So much so that the San Bernardino County Sheriff actually issued a warrant for $75,000 for any tips that will lead to unauthorized drone operators. Later on, some say that was kind of may not have been true in the sense that the pilots maybe saw things that weren't there. I can talk from experience, though, being at a firework, July the 4th fireworks. This was also out in California, the Los Angeles area, in the middle of the city at night. Everyone was there watching a firework, and there were a couple of drones flying around where someone was illegally operating them, it's happening, which is not a good thing. Second one, there have been cases where there's been interference with aircraft around airports. And I just pulled out an excerpt from, in this case, it's Transport Canada, so they're having the same issues we're having, where a drone came within 10 feet, or 10 meters, I think it was, of 10 feet of an aircraft that was on approach to landing. Again, something that shouldn't happen, but it's happening. The last one, which is kind of put here for comic relief, and it was, well, if you were the guy involved, it was not funny. This happened out in San Diego this summer, and it was all over the news down there. A family was out at the beach, relaxing and enjoying themselves, and a person who was doing real estate surveying or something akin to that had a quadcopter where he started flying it over the family very closely. Father got annoyed, took a towel or his t-shirt or something and threw it, and it got tangled up in the rotors of the quadcopter. The quadcopter crashed. Cops came up, and of course things took a strange tangent at that point. They actually arrested him for vandalism and threw him in prison, in jail rather. Actually, he was let go later on. But the point is we have privacy violations that could happen, interference with public good, and interference with aircraft operations. So there's got to be some care taken when these things are being used for either infrastructure, anything you want to use them for. Just be aware that there are laws there, and the laws are there because things like this can happen. So if there's anyone in the crowd that wants to use UAS for infrastructure, applications, anything that you want to use them for, the advice is, first of all, don't operate them without authorization, and you may find yourself as part of a some sheriff bounty. In this case, that's the actual bounty that was issued by the San Bernardino County Sheriff Department. So don't do it illegally. And if you want to do it legally, there is a way to do it. All right? So if you are in no hurry, and you could wait till 2016, so a year from now, then there is going to be a set of rules that are issued. The FAA issued a notice for proposed rulemaking last year. They've got all the public comments in, and the plan is in about, 2016, they'll issue out a set of rules that will streamline all UAS operations for the small UAS. So if you're interested in an application, then you could look at those rules, and I'll give you a highlight of them. And if you fit within certain requirements, you could go ahead and operate without much of an issue. So the rules are coming. So there is going to be guidance for how to operate these vehicles. On the other hand, if you are really chomping at the bit, you need to go out there and operate a UAS now. There are legal ways for doing this. And there are three, actually there should be four ways. I haven't included the fourth one, but the one is you could operate your UAS at one of the FAA test sites. That doesn't do you any good if you have an application where you're trying to inspect things or apply them. But if you're trying to test out new ideas and new concepts in a controlled environment, then these test sites are potentially useful for you. There's 6 of them around the country that have been established. Actually, there's one very close to us in North Dakota, so it's a official test site, and you could contact the site operators and go and test out ideas and operate them there. If you don't want to do that, then there are 2 other options. One is you could get what's called a Certificate of Authorization, or COA, which is basically only granted for public operations, so state agencies, or if you're doing work for the federal government, you could get a COA, which basically is a plan of how you're planning to operate the aircraft, how you're maintaining them, etc., that you submit to the FAA, and they will approve it, or they'll give you comments and make changes to it to approve it. So there's a way to do it legally. That's what we do here at the U of M, at least in our lab. We have a process where we get COAs and we fly them using COAs. If you're not a public agency and you want to do this on your own as a private entity, then there's something called a Section 333 exemption that you could get. Again, the procedures are there. You could apply for them and get the permit to operate them legally. There are restrictions. You can't operate around airports, for example, or you can't operate around busy areas where there's busy air traffic. You can't operate around where it could be potential hazard to people around, and so on and so forth. So there are restrictions, but there are ways of doing it. I mean, I've heard some folks that have applied for these complain that it takes too long to get. Our experience has been that the turnaround has actually been pretty good and pretty quick for us to get permits to do what we need to do. And again, in the precision agriculture work we do, there's a collaborator of ours up at Crookston who has quite a bit of these COAs all over the state for operating quadcopters. And again, they've figured out how to do it, and it's doable. So, moral of the story: there are ways to fly these things legally. Don't fly them illegally. That's at least one of the messages I want to impart with this talk. If you can wait till 2016. Here are the rules that are coming down the pike, which will, again, if you could show that your UAV satisfies or US satisfies these requirements, then you really don't have to talk to anyone. You could potentially go out and fly them. And the rules are going to be, first of all, your UAS must be less than 55 pounds. So it's going to be in that Class 2 or Class 1 or 2 category. It can't fly more than 100 miles per hour, which I don't think is an issue for most of the UASs that are going to be used for infrastructure management and applications. Less than 500 feet above the ground level, and so on. Here is an interesting one. You're not supposed to operate them directly over people that are not directly involved in the operation. Now, as part of the Project Pathfinder initiative, CNN is working with the FAA to come up with the technologies, the rules, the ways that can be allowed, because they want to use it for news gathering purposes. So maybe in the future there might be a way for doing that, but that's still something that's being explored. Daylight operations, don't fly them at night. Line of sight operations, you have to always be able to see the UAS. You can't send it over the horizon to do something where it's not in direct view of you, and become obvious when I start talking about technologies in a second why that is. And then on the operator side of the house, there's all kinds of things that they're going to require but one of them is that anyone can't go out and operate these UAS. It's going to have to be someone that is going to be vetted by the TSA for obvious reasons. So, but there are rules coming out, and once the rules are out there, then there's going to be a streamlined way of operating these small UAS. With that, this will solve some of the problems, not all of it. So what are the technical challenges that remain, that have to be addressed? So there are two of them, at least as far as I can see them, and the challenge, one of them, is reliability and robustness. Can they be made reliable? Right now, reliability is kind of on the atrocious side, and partly because a lot of the hardware that goes into these small UAS come from the hobbyist or remote control aircraft community, and they were never intended to be reliable, industrial grade type of systems. So they're not particularly reliable. But the other part of it is almost all of them, and we'll talk about this a little bit more in detail, rely on GPS or GNSS, which is a general encompassing term for all kinds of GPS systems. They all depend on that, and whenever there is a denial, a stressing, or spoofing of GPS, bad things happen, and I'll show one case study where something really went bad with a particular UAV when they lost GPS. The other one, which is not really a big issue with the small UAS, is the problem of sense and avoid. And that is, how can you detect other aircraft in the vicinity or other collision threats and avoid them? With the small UAS, because the laws are going to be you can only operate these when they're directing line of sight of you, that issue goes away because the operator becomes the person that makes sure that collisions don't happen. But for the larger UAVs or for over-the-horizon type of operations, this is going to be a big challenge. And it's a big challenge, and this is the only thing I'll say about it, because if you take a look at the way aircraft operate these days in the national airspace, there are layers and layers of defense to make sure that you don't hit someone else or that you don't have collisions. So for example, if you're flying in a condition where you're able to look out the window and the weather is good enough that you could see other aircraft around, there are two layers of defense. The first layer of defense is this thing I've drawn here, which is gray, which is the airspace and procedures. So that chart I showed you at the beginning, the national airspace is broken up into all kinds of different groups. That has associated with all kinds of procedures that say you can fly here or you can't fly here, so on and so forth. So there's a big layer of defense there that prevents unsafe operations from happening. And then at the closest level, there's the pilot's eyes that prevent aircraft from colliding. The pilot's eyeballs act as a sensor for preventing that. If you're in conditions where you can't see out the window as an operator, there's still layers and layers of defense, air traffic control radars, procedures, and onboard equipment that make sure that you are separated. So for UAS, what air technologies are there that are going to make the substitution for the pilot's eyes? That's the whole sense and avoid problem. Can we put sensors on board these vehicles that are able to work with all of these defenses and at last substitute for the last one, which is the pilot's eye, being able to see other collision threats and avoid them. For the small UAS line of sight operations, that's a non-issue, but again, this is a big challenge, and there's a lot of, a lot of energy and a lot of effort being thrown at it. But again, it's a non-issue for the small UAS that are used in infrastructure inspection and infrastructure management. So, what are the other technical issues? Well, as I said, what I'm really going to focus on for the rest of this, for whatever's the remaining part of this talk, is the fact that all the UAS guidance systems that are used for keeping them afloat and controlled all rely on the availability of GPS. GPS is central to them. And what I'm showing here are 3 different types of autopilots that are used for controlling UAS. These are basically the brains that guide the UAS. That's, again, a professional off-the-shelf solution called Kestrel. They're the hobbyist versions that you could buy, which, again, if you're using these for actual useful revenue-generating services, perhaps you may not want to use hobby open source version. And here's a research version that we here at the U of M have built, which, again, in our case, I'll tell you why we have something like that we use. But all of these systems, all across the board. At the heart of them is GPS. So if GPS is unavailable for some reason, their performance suffers real badly. And the reason for that is if you take a look at the onboard control system on most flight control systems that are in the UAS, they look something like this. They have a control system for basically manipulating controls and taking the aircraft where it needs to go. There's a guidance system that basically generates paths as to where the aircraft should go. And then you have a navigation and attitude determination system that determines where the vehicle is so that you don't collide with things and what the orientation is for control. And all of that is fed with sensors, and the key sensor here is GPS. So when GPS goes away, most of these systems start behaving rather poorly. And in particular, the position estimate suffers real bad. As GPS goes away, what you see with these UAS flight control systems is the position solution starts drifting and starts becoming very large. So if you're trying to fly, for example, a UAS close to a bridge or close to some sort of an infrastructure, hopefully I didn't break this, then if GPS solution goes away, then that position solution is going to start getting poorer and poorer, and you're not going to know whether or not you're at a collision threat or not. So the reason I brought up that picture of the bridge, if you're operating close to a large metallic structure that's reflecting GPS signals, you're going to start getting degraded performance. And so you're not very sure your position solution starts degrading, so you got to be careful about that. Anything that's a large reflecting surface is going to start affecting GPS solutions, so that's an issue. The velocity and attitude estimates also become very poor, particularly in the case of attitude, which is basically the orientation of the vehicle. In a roundabout way, it almost always depends on GPS being available. So bad attitude estimates usually lead to loss of control. So that's kind of a secondary effect. But when GPS goes away, you could potentially have also these kind of issues. Now, many of the flight control systems also have a fallback procedure where they continue generating good velocity and position estimates. Good velocity and attitude estimates, but almost always the position solution is going to be pretty bad when GPS goes away. So there have to be alternatives for using GPS. There are alternatives that have been looked at. Vision systems are being looked at, and again, some autopilots do have the ability to use cameras and camera-based navigation for locating themselves. There are others that are looking at the concept of what are called signals of opportunity. In this case, why not use signals that are all around the city that are not necessarily, or the environment, that are not necessarily designed for navigation purposes, but you could extract navigation information out of them. Radio signals, TV signals. We've actually done some work using cell phone signals. We were able to put together a system that allowed a UAV to limp back home after GPS was denied, but again, not very accurate, more work to be done there. And then there are ideas that are being floated around where you could use networked navigation, where it's the whole concept, or the buzzword these days, of the Internet of Things, where if you have a flock of UAVs that are perhaps inspecting a bridge or working together, then cooperatively they could start exchanging information whereby they could try to keep their position solution in check even in the absence of GPS. So what I'll do in the next few slides is actually talk about some of the work we've done in this area to show you that it's actually a potential solution. But the point, I think, the most important part of it is that all these flight control systems are, again, small, have very little, usually the computational horsepower is not very high. So there's not going to be one silver bullet solution that is going to work for all applications. It's depending on your application, depending on the mission you're trying to apply for, you will have a backup system for GPS. Either it's going to be a vision-based system, it's going to be something that's maybe a signal opportunity system, but it's going to depend on what the application on hand is. I'm not convinced that, and it may happen, but at least right now, the flight control systems that are out there for small UAS they don't have the capability for doing all these different things. It's GPS and something else, or vision, GPS, and something else. So depending on the application, depending on the mission, there's going to have to be some sort of a backup for GPS GNSS. So the idea of cooperative navigation or network navigation with UAS, this is an idea that we played around with, looked at. And again, the idea is, imagine, if you will, I have an operation where I'm inspecting perhaps, say, a bridge. I have a UAS, a quadcopter in this case, that's operating under the bridge, which would be a case of an area where GNSS or GPS will not be available. At the same time, you have others that are cooperating, that are sitting outside, flying, and are in view of GPS satellites. These UAS will be able to get GPS solutions and have very accurate position solutions and attitude solutions. On the other hand, this one will not. So is there a way, for example, to have information from these UASs be supplied to this other UAS to help it in figuring out where it is when GPS is not available in this particular operation? So if you network these vehicles, can you do that? And the answer is somewhat, and it's one potential way to deal with the GNSS denial or the unavailability of GNSS when you're operating in places like this where, again, a lot of these applications, under bridge, close to structures, is going to be a case where the GPS services are not going to be the best. So it's kind of common sense if you think about it, or maybe not, but that if this vehicle here has a very good position solution, and this one could range somehow, either by measuring time of flight of a radio signal or by some other method, could figure out where it is relative to this one, then it should be able to figure out where it is, and there should be a way of flowing down information into that particular third UAS. While it appears that it's straightforward, in reality, when you put things together like this, there are all kinds of issues that come up. And in particular, it turns out that if you don't design the network the right way, you could end up having cases where the entire community ends up becoming destabilized because errors from this one, for example, will end up feeding up into here, and if this one exchanges information with this one and goes back there, then you have some sort of a feedback that causes things to destabilize. But anyway, I'll spare you the details of the estimators that were put together for doing these kind of things, but I'll show you results. So stepping back, one of the things that we're interested in is using UAS for these applications. A lot of these applications, GPS is not available. You're maybe under a bridge or you may be close to a structure. So if you're cooperating with other UAS that actually have visibility towards GPS and you're exchanging information, how well does that work? So these are actually results from actual UAV flight tests that we did to test out this idea. And in this case, we had a swarm of 5 UAS that were operating in a GNSS denied environment, so they're under a bridge doing an inspection, for example. And then he had 2 of them that were actually out and they actually had visibility towards GPS, and they were exchanging information for that purpose. So these lines show the performance. So each one of these lines represents a position error growth. So what you see, this line called coasting, that is the solution of your traditional flight control system that you'd find on a UAS when GPS goes away. They all use inertial sensors that are measuring rotation rate and acceleration, and that, without GPS arresting those errors, will continue to grow. And in this case, you see after 5 minutes of operation without GPS, they're way up at the 800 meter or the kilometer type of an error state. There are all these other types of approaches, but let's just take a look at the 2 lines here at the bottom. So HF stands for high flyer, and that means this is a UAS that's outside and actually being able to see GPS, and it's communicating with these other 5 that are not seeing it. And by doing that, you're able to actually keep errors in check, and at a fairly small level, less than a few hundred meters, or actually in the case of this particular case, more than on the order of tens of meters. But the point is that this is after 400 seconds or 5 minutes worth of operation. So for most of these operations, you're going to be doing ins and outs out of GPS denial, so you're not going to be actually operating for a very, very long time. So the cooperative approach might be one way to answer some of these questions with denial of GPS services. But the bottom line is there has to be a way of switching back and forth from GPS being available and not, because again, flight control systems that are out there for UAS, off-the-shelf solutions today actually almost all rely on GPS being available, and without GPS, they're not going to work very well. So that's a big challenge that has to be addressed. A non-GPS-based navigation system that is as good as GPS to help in these kind of operations. Again, vision is a good candidate, and it's been used successfully, but it's not the catch-all, it's not the solution for all problems. All right, so the last one that I'm going to talk about, and it's one that's actually catching some attention, is the notion of position authentication and geofencing that's being talked about, and the use of UASs for all kinds of applications. So here's a map, just to put up a hypothetical scenario. Here's a map of the area around the U. I have the railroad tracks, and I'm imagining that I have a UAS that's out there doing inspections. Here's the TCF stadium, where there's going to be lots and lots of people on football days. So it's definitely not legal to fly a UAS over populated areas. So how do you make sure that a UAS does not stray and go into areas where it's not supposed to go to, right? I mean, there was the case with UASs flying into places in Washington, D.C. where they're not supposed to be, right? So the idea of geofencing is coming up. So the idea is you'll set up a fence, it's going to be a virtual fence of some sort, around some area that will prevent the flight control systems on the UAS from going past that region. So, and some of the UAS, some of the quadcopters showing up now are starting to have these things in them where there are places that are no-go zones. So if the GPS position solution says you are here and you're not supposed to be here, then you don't go in, all right? So that's a geofence. But there are issues that remain with that, and there are two that are actually being brought up. One is, how do you police this? How do you make sure that a UAS does not violate this? One way you could do it is potentially ask it to report back to some central authenticating agency, I suppose, that's doing that. Basically having something equivalent to a flight air traffic control system. That's an idea that's being looked at. There's a whole series of options of them that are being looked at by NASA Ames, but that's one potential way of doing it. The other way of it is you could trust the actual system on board to do this. But either way, there's a danger, and it's a real danger actually, that you could have the case where, in the case of the report back, they could say, I am here, when in fact they're past that geofence. Or you could somehow rather spoof the system on board to think that it's here, when in fact it's in this space. Now, with GPS, this is actually a possibility. As a matter of fact, Todd Humphreys, who was the speaker here last week, a couple of years ago, showed that he could do it very easily. You could actually design spoofers that are able to grab hold of a GPS receiver on a particular vehicle and steer it away from where it thinks it is. So it's getting easier and easier to do. It's not trivial, but it can be done. Now, if you look at GPS, the signal that comes down from the satellites, there are several versions of it. There's a version that's only available to Department of Defense authorized users. That version of the signal has a module built in it called the anti-spoofing module, which will prevent you from doing these kind of things. So the question that is being asked is, with GPS, can you come up with, for the civilian version of things, can you do something equivalent to that to prevent someone from spoofing? There are many solutions being thrown around, but again, it's a real issue, and it's something that has to be solved before we start seeing these vehicles flying around day in and day out. I mean, you could think about the Amazon delivery model, right? If you could spoof it, then you're going to start getting a lot of free stuff rather than having to pay for it, right? So that's a possibility. So there are two ways to cause this problem. One is what's called a false position report, and the other one is sensor falsification. We've done some work in this area in the past couple of years to come up with solutions where basically try to use the existing GPS signal with a little bit of smarts, some signal processing tricks, to make sure that we could authenticate actually that someone is where they say they are. It's a system that was put together. It's basically what it is, it's a system that would sit at some trusted authenticator site. The vehicle that's operating will periodically send a snippet of the signals that it's seeing back to this authenticator. The authenticator will compare that signal to what's coming down from GPS satellites and decide whether or not the person is lying, or if they are where they actually are. And the way it works really is, the analogy I give is this one. The GPS signal has buried in it if you want to think of it as a watermark that no one knows about except for DoD authorized users. However, if I take a copy of that signal and I take a copy of a signal from somewhere else, I could put the two together and I don't need to know what the secret code on that signal is, but I could do the matching to authenticate the two and figure out whether or not what I'm seeing is a false signal or a true signal. And this was something that we tested out, that's about coming on 2 years now since we actually did this, where we put this authenticator together and then we took a GPS receiver, we put it at point A, and initially we said, have it report back saying I'm at point A, and then we had it move to point C, point D, and point E, but at each time it got there, it still said I'm at point A. So in other words, it was lying. And would this authenticator be able to catch it? And the answer is yes, it does. And at least the way we put it together, it's able to pick out position false reports that are within 15 meters. So if you are not within 15 meters of where you say you are, it will raise an alarm. Now, this was a cool, interesting, fun project to do, but I don't think this is going to be a very practical way to do it for UAS because, again, it's going to require that you have an authenticator, a trusted agent, and the UAS is periodically sending signals to it to do this. That may be too much bandwidth, too much, might be cumbersome. So there's got to be some sort of a different way of doing this authentication. And it's actually an issue that's been flagged. And again, NASA, I guess the folks at Ames that are looking at the introduction of UAS in large numbers into the airspace for doing all these infrastructure, surveillance, package delivery applications, that's actually one of the big problems they're looking at is authentication, is how do we authenticate that a UAS is where it says it is or where it should be. So with that, I'm going to try to stop it here, but the summary, the key points I wanted to get across is, one, there's no doubt that UAS are going to improve the efficiency of all kinds of operations related to traffic infrastructure management, traffic management, and things beyond. Currently, there are ways to operate these aircraft legally, provided they're less than under 55 pounds. So if you're interested in operating them, there is a legal channel for doing that. The rules that are coming out in about 2016 are going to make it even easier and more streamlined. But even though the regulatory issues will be addressed, there are some issues that are going to remain. The beyond line of sight operation, the sense and avoid problem is a big one. It will still be one that we need to deal with. And the robustness to GNSS denial. We become so used to GPS and so addicted to it that everything is actually designed around it. But however, it has some really shortcomings. It's easy to jam, it's easy to interfere with. And in places where you could use these UAS, it's not going to be available. So how do we deal with the lack of robustness to GPS and deal with that issue in UAS? So with that, acknowledgements. The UAV lab here at the University of Minnesota, it's actually got quite a bit of people and students working in it, so there are many, many more I could list, but acknowledgement to them. Sponsors, we've had different sponsors, and the last one is many years ago when we kicked off this project. When we started working with the UAS, we actually got a seed grant from MnDOT, SRF, and actually I should say ITS, not CTS, but ITS, so that work was one of the things that actually got us off the ground. So with that, I'll stop and I'll open the floor to questions if there are any.
Just remember, you need a mic.
So you mentioned Amazon, and of course they've gotten a lot of media attention, as have other commercial operators who are interested in using drones for delivery mechanisms. Given the new rules that you're expecting in 2016, in particular the line of sight rule, I'm interested in your perspectives on how likely that is to actually happen in the near future, in the long-term future. I'm just interested in your perspectives on it.
So with the rules of 2016 are not going to allow them to do those kind of things. However, this Pathfinder initiative that I talked about, again, it's a program where the FAA is working with 3 different entities, BNSF for the beyond the line of sight operations, CNN for operating around crowds, and then there's a third one, I'm trying to remember who it was, but they're looking at the problem of extended far distance operations. So the rules are not going to address the Amazon question, but these 3 issues are there to address those kind of operations. So I think it's step-by-step procedure, but the rules that are coming out in 2016 are to help people that are trying to do bridge inspections, smokestack inspections, things like that.
I'm just curious if you, being involved in the development of these systems, is there any feedback from different industries that raises concern for the replacement of labor? So you talked about your example of the rail industry, for example. That's a lot of man hours put into inspecting all those feet of track. Or is the attitude more so that these systems are going to enhance performance and efficiency of the labor that's already in place, and it's actually going to create, kind of a expertise in these systems?
Okay, so I can't talk definitively about all of them. I could talk a little bit about the one with the railroad inspection. And that one, at least what BNSF is saying is that it's going to team up UAS with inspectors to make the inspections more efficient. So I don't know how you want to read into that as to whether or not it's going to be a replacement of workers, or if it's going to be a force multiplier of their effort, but don't know. But at least with again with the railway inspection, that's the way it's being told.
Oh.
I'm very interested. So when you were talking about the coordinated navigation system, so the series of drones that talk to each other to try and create some robustness in the system, especially if the GPS were to conk out, with the rules that are coming up, could one person have line of sight in your instance of, say, all 5 of those drones and be legal, or would you have to have 5 separate operators, one watching each of the systems you have up and
I believe
up
you
and
could
running?
have one operator if they could see all of them, right? So if they're within, I'm almost, well, I shouldn't say I'm 100% sure, but I think the way they are right now, it would allow you to do that, so a single operator. So if you, again, the way I'm thinking about this is if it's a small area where you can see them all, it would work. But again, down the road, if we could start doing line of sight, beyond line of sight operations, if there's a way to cooperate, there's something to be gained. But again, it's not the silver bullet. There's all kinds of issues associated with that as well. So I think the solution for working with GNSS denied operations is going to be different for different applications.
Are there any examples in other countries where we don't have the FAA and the FCC of them doing things that are exciting, interesting, different?
The one that, I know a little bit about what's going on in Canada, and it's not terribly different from what's going on here. So that's the one I'm more familiar with. I'm not sure how, and again in Europe, I know that they are, from what I understand, they're not at the point of issuing like an equivalent to the NPRM. At least that's what someone was, that is knowledgeable, was telling me, but they're going there and they're going to have something equivalent to that. So I'm not sure, I'm not 100% sure as to where we stand compared to the rest of the world, but my impression is that we may be a little bit ahead, but I've heard otherwise, but I don't know if I haven't seen the evidence that that's the case. But again, Canada is a little bit similar to what we're doing.
Any other questions? Anyone have anything tugging at them that they want to ask? Well, if there's nothing else, thank you. Please join me in thanking Professor Gebre-Egziabher. Next week, we have Professor David Noyce speaking. He is the department chair for civil engineering at the University of Wisconsin-Madison, and he'll be talking about a variety of issues related to maps and road curvature, being able to identify road curvature in order to develop safer systems to prevent people from driving too quickly around curves. So anyway, he'll be here next week, same time, same place, Professor David Noyce, and he has a long history of working on various safety systems with traffic signals and other issues going back quite some time from Madison, Wisconsin. Thank you.